Okay. Hi, guys. It is Dr. Erig. Thank you so much for coming on. We just got a couple more things I got to work with. So give me a second. I want to be able to see your comments at the same time. So I've got a couple things to move around. This is going to be muted. Let's see. So we'll start off by having the comments there. Move this over. If you can hear me, can you just text back that you can hear me in the chat box? Because I want to make sure that you guys can hear me okay. This is going to go here. Whoops. And then I'm also doing this on Nearpod. So if you have two devices, it might help you to participate on Nearpod too. And what Nearpod is, let's see, I don't know why I can't get this diagonal. Nearpod kind of lets you participate as you go. Can hear. Awesome. Thank you very much. Awesome. Okay. I don't know why it keeps doing that on me. All right. So this is where we're going to spend most of our time here. So if you have two devices, like you're watching on a laptop and you have your cell phone, you can definitely see it on Nearpod too, but that's just FYI what that is. All right, and we're almost ready. Perfect. Let's move my head down and then we'll get started. Okay, cool. All right, so yay, we're here. Let me just do one more text that we're on live. I'm sorry, I had to switch computers. That was part of the delay. For some reason, it wasn't working well on my laptop. So let me just do one more announcement. Hopefully, you should have the following things with you. You need to have paper and a pencil. If you're just going to watch me and not do any work or write anything down, it's not going to help you at all. So please, please, please consider having a paper and pencil. Also, if you have a calculator or your cell phone, that is perfect. You can definitely use your cell phone calculator. That's what I'm going to be using. And have something to drink so you don't have to like focus on, oh, I'm thirsty. Should I step away? Should I not step away? So that is basically what you need to have. If you came on Thursday, also if you have your orange packet, I talked about how we're going to finish the orange packet today. So you can have that with you. If you don't have the orange packet, it's totally fine. You have a paper and pencil. If you're one of my students, we have our red EOC notebook. So you also can go through that, especially we're going to be looking at the crazy quick review sheet. You either have it in your red notebook or you have it as one of your, the yellow paper you picked up in the comments heading to the A building, or I just snapped it out on Remind. So those are the different options that you can have. If you're not on my Remind, you're going to text at ERIG to 81010, and then you will be on my Remind. So this is going to be so different than after school review because we have, I'm going to say, unlimited time. Now, really, do we have unlimited time? No, I'm not going to be on here till your test tomorrow morning or Tuesday, but we are going to go slower. If you have questions, feel free to ask. That's perfect. Also, I'm going to start by going over what we didn't finish on Thursday, but I'm going to revisit some topics after that. That I did talk about on Thursday, but went really quickly. So you can tell me to slow down. You can tell me whatever you need me to do so that you leave feeling like you have a better understanding of math. You can participate either via Remind or you can participate in the chat. Either way is totally fine. Just ask your questions as we go. Also, so you know, there is like a 5 to 7 second delay from what I actually say to what you hear through the YouTube live service. So if what happens is you have a question, please let me know and don't feel like I didn't hear you. It just hasn't come up on my screen yet. Hello, everyone. Yay, we're here. If you stayed after school on Thursday, you saw this. And what this was is I had you set goals for what you wanted to achieve on your EOC. And not only that, but that you're committing to yourself, not just to me, to be successful. It's being growth focused. And so the fact that you've signed on, that's good. If you need a brain break, take one. We will embed brain breaks too, because I'm going to want a break. And I don't want to just go straight, but just so you know, you will have that also. So this is what we had said. This is kind of a picture. And if you were after school on Thursday, you remembered on the top of that line was the stuff that if you took the test right this minute, what would you get? And our goal was the bottom of the line. Those are the goals that we set. So we can see we had a pretty big spread. Most people were between 50 and 90 in terms of wanting to be successful or having been successful on the test. Realistically, some people were like, dude, I'm only at 50%. That's totally fine. Our goal, you can see most of us are in the 80 to 90 range. 80 to 90 is proficient, 93 is distinguished. A couple people in the 70s. Now, our goal is 80 and higher. 70 or higher, we'll take. We'll still put the 70 in the grade book, but that's what we're shooting for. So please, if I go fast, tell me. If you need a break, tell me. I'm here to help you today. So I've kind of budgeted till 8 o'clock. That's when we all need to be done with this. So you don't have to stay all 4 hours. Stay for my part. But if there's still questions afterwards, I've got your back. We talked about this a little bit on Thursday. I want to revisit this. This is what you can expect tomorrow. You can expect a minimum of 58 questions that are multiple choice. That's the minimum. From there, you can expect at least one question that's technology enhanced. Technology enhanced, I'm going to show you coming up. That's like dragging and dropping, rotating. You can expect 2 constructed response items, and those regular constructed response items are not very long. It's like 1 or 2 sentences tops, sometimes as simple as a number. You can expect, and I should say at least because of the field items I'll talk about coming up, you can expect 1 full extended constructed response, and that typically has 2 parts and the word explain in it. And then 11 field test items. Here's what suckle-doodle-doos. They don't tell us what the field test items are. So you might end up having 3 extended responses. It's completely random. So the top part is what you're graded for. The bottom part is just extra, but they don't tell us. This is the breakdown. So we've already talked about congruence and simile. That's 35% of your test. I will revisit that today. We talked about circles, not circles in terms of equations of a circle, but more like arc to angle, divide by 2, angle to arc, multiply by 2, area of a sector, things like that. Equations and measurement, we did not get to on Thursday. So that's what we're going to start when I start teaching today. And I have embedded some extra stuff coming in here just because I want to give people time to sign on. CR at the top means constructed response. Here, well, there's 2 different things. So it's selected response means multiple choice. The CR and the NRT relate to points that go toward your grade. So some of the stuff, like of the 20 points you can see right here. Ooh, I forgot to bring up my Epic pen. Hold on 1 second. For, as you can see here, that's what's going to be counted toward your score. So 20 of these NRT are questions that you're going to be compared to other students in the United States. So of those, 10 points will come from the selected response. So that's what that is. Again, equations and measurement, which we didn't cover, we're going to cover now. That's 35% of the grade. And then statistics and probability. I'm going to revisit a couple things because I definitely went super, super fast. So I want to revisit a couple things on probability because the 2 of the easiest things I went too fast on. Next, this is supposed to be a link, but it's not seeming to come up. That one came up. This one did not come up. All right, we'll just Google it. So I want to take you, some of my students already saw this, not everyone did. So I'm going to kind of take you through the Georgia experience online to give you an overview of the tools and what you're going to see tomorrow when you take the test. When you take the test, you would have hit that blue button. So this is what you can expect for math. Now you've already seen it for ELA, thank goodness. So you shouldn't be completely lost. You're going to be in assigned seats. The assigned seats are random. You will not get a calculator. The reason why you will not get a calculator is because the first section of the test is without a calculator. So if you want a calculator after you do part A of section 1, you will have to raise your hand, and then a teacher will give you a very inexpensive, teeny weeny, nothing fancy calculator. So you will get use of the calculator on here. This calculator is like, not the best, but it's enough to get the job done. For some people, they'll prefer the smaller 4-function calculator because things like 27 times 5 might be easier to type into the calculator instead of typing it into the computer calculator. P.S. 27 times 5 is 135. All right, so we're loading the test data. Most of these, you should be familiar with the directions. You should be familiar with the pointer tool. Hopefully use these tools on Thursday and Friday when you took your ELA. What is different is the location of the reference tables, which you probably didn't see, as well as a couple other things. I think we start at 12. Let's see. We do. So here's an example of one of this might be considered an extended response question. So you have your standard multiple choice questions here. You do have the highlighter tool. Remember, the highlighter tool is going to draw a box. So if you need to get out of it, you're going to always go back to the pointer tool. You can add sticky notes. Some people might pull up the formula sheet and then might have like the sticky note and write down the formula that they need. You can do that for sure. So the formula sheet is where it says X plus Y. I believe you will have access to the graphing tool. The graphing tool just lets you put in one equation at a time. If you have it, for example, and you have to know, like, I forgot where Y equals X is, you can graph it and kind of see wherever you put your mouse, that ends up having it down here, shows you where the coordinates are. So that's what you can look at for that. Additionally, here's the lovely calculator. Now, it is very basic, and I know you're so used to graphing calculators or the yellow calculators. I get it. Basically, this is what we have. Now, there's two things that if you look right away that you can see that are missing. There's no sine, cosine, inverse, and hi, Jamani. There's no inverse and there's no square root. So the way that you get the inverse and the square root is you hit the second button and that's going to give you that function. If you have to take the cube root of something, that's what this button is with the little X. So you would do like 3, then the cube root button, and then let's say 125, and then you'll get your cube root of that. So the only time that you probably will end up doing cube root is if you think of the volume formula of a circle, 4/3 pi r cubed. If you have to work backwards, you would need to take the cube root, and that's there. Then if you're like, well, now I don't know where everything is again, hit back to the first, and that's going to show you all of those tools. So here's some examples of the constructed response. We're going to look at that coming up. Here, where it says, what is the total number of observations in these data? They literally just want a number. They don't need a sentence. The people grading this don't care about your beautiful grammar. All they want to know is what's the number. So you would count however many things are, type your number, done. Here, it says, what's the difference between the mean and median? Again, this is just a typed number. It doesn't say explain. So you would, again, type your number in. Now, you can explain and you can give them more information, but that's where it comes in for part C. Here it says explain your answer. So now you're going to go into a little bit more detail about how you achieved your answer. Now, best practice I'm going to show you coming up is if you, sugar shoots, is if you show all of your work. So let's take a look at this next doc. So right here is released items. I was surprised. I actually just found this weekend. These are released items about how to score the test. So let's take a look at some of the things that they have. So here is an example of a constructed response. This problem you probably saw in a different version if I had taught you on Friday. Here, it wants to know what transformation or series of transformation maps ABC onto triangle AEF. Now, I'm going to wait a minute, and if you guys can please type in chat or via remind, what do you think you should put down for a good quality response for part A? So right now, you're going to be typing in, what do you think part A should be? and I'll wait. So I'm also showing the video. There we go. We've got something. There was a translation and a dilation. Thank you for participating. Great job, Baron. Anyone else got anything else to add? Dilation of 2 and a reflection across the y-axis. Very good. That was really well done, Brichonnet. Reflection and dilation, reflection, dilation, reflection. Oh, there's some more of my students. Hi, names. Good to see you. Okay. Yes. So of all of those answers, Brichonnet is the one that gets the money because she was most specific. This right here is a 4-point question. I believe it's 4 points. We'll double check in a second. You need to be very specific. So let's take a look. So the first part of it right here shows us that we need to, if you said it's a reflection across the y-axis, then a dilation, that gives you 1 point. You would only get x equals 0, dilation of 2. Actually, that's also excellent. You could definitely do that too. So don't just say reflection, dilation. Be specific. What did it reflect over? Thank you. Well done. And what was the scale factor? Okay. You would get 1 point if you don't know the next part. Now, here's the next thing I want to show you. See how it says angle? Right here, it says angle, 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 angle. Now, if we go back and look at this, right here, when I first looked at it and did this problem, I got it wrong. I got it wrong because I'm thinking, dude, these shapes are not congruent. It's wrong. But it wasn't asking about the triangle. It was asking about the angle measure. So you're going to have to make sure that you take some time and pay attention what it's asking. Again, notice how this says onto. That makes this the pre-image and this the image, which means this is the first and this is the second. They could ask you the reverse. Make sure you pay attention to the order. All right, let's take another look at some of these. Here is an example dilation with the center at point A, with the scale factor of 2, reflection over the y, and then it talks about corresponding angles. If you miss some of it, then you won't get the full points. So here, flip it over the y-axis. That would have only given you 1 point. Here, reflect over the y-axis and then not mention anything with similarity. That would have earned you 0 points. Okay, again, incorrect responses. Here's another one. This is an extended constructor response. So this one is worth 4 points. Again, most of us saw this already in our classroom. Okay, excellent. I see the remind also. Well done. Here, it wants you to write the answers, find the links, and write the answers. Now, even though it doesn't say explain, it still wants you to show the work. So in this particular problem, there's 2 ways that you could do it. One, use the distance formula, okay? Because it says find the lengths. Find the lengths of the 2 sides, and it wants the distance formula for that. The other thing that you can do is so we can, because it says lengths, we can either do distance formula, or if you remember from December, you can do Pythagorean theorem. And we can count that this is 3, this is 4, this would be our x. So we would do 3 squared plus 4 squared equals x squared. 9 plus 16 equals x squared. And then you have your 25. Now, as a reminder, when you write the responses, it's going to want the full response. So let's take a look at what that specifically means. Here, it says the length of KL is, this is what they say. Oh, this is the minimal one. Thank goodness. I must have jumped too far ahead. There we go. So here you can see the person showed the work of how they did the problem, and then they gave the 2 slopes, okay, or the 2 lengths. And here's another example. Here they did. Here's what they did for the Pythagorean theorem or the distance formula. Because they're not the same, the shape is not a square. Here they did the slope. It's okay that they messed it up. They still earned a score of 3. A score of 4 is more detailed. Again, your tests are on the computer, so you would have to type out how you got it. But still, there's no introductory sentence. It doesn't say slope measures the change or rise of a run. There's no like huge introductory sentence except for this. Slope is rise over run. And so that is explained how they got it. You could also have put in the distance formula. Okay. Again, I think we've pretty much beat that over. You know, even if you only have partial answers, like here, this answer was correct. This answer was correct. These were correct. But it's still minimal understanding. Here, it says, I know the shape is not a square because the sides are all straight lines. That has nothing to do with what's a square or what's not a square. So that's why you want to pay attention. All right, let's keep moving on. Okay, so equations and measurement. Finally, we're there. So volume, density, equation of a circle, distance formula, midpoint formula, quadrilateral properties, and completing the square all fit in this particular category. So let's take a look. Again, the volume formula is on your formula sheet. I want to remind you about the base. Remember, big B stands for the bottom. So like if I have a pyramid, which is not the best pyramid, that base stands for this square, which means really it's going to be length times width. And then you're going to put it in. So just remember that piece of information for when you take this. Zoom in. I'm not sure if I can do that. I will see. Let's see. That is about as zoomed as it's going to let me get. I'll try to write bigger and I'll try to write thicker. Okay. So let's go back to here. And if I stick with black, you should see it. So here we've got the volume. No problem. The volume of a cylinder. Because it's cylinder, I know that the formula is pi r squared height. Then what I'm going to do is it wants to know the volume. And the reason why I picked this up is because I want you to remember to, before you work the problem, check the answers. Because every single one of these answers have pi in it, when I do the calculations, I'm not going to type pi in the calculator. I'm just going to do the r squared h and then leave the pi on the side. So here I'm going to do, back to here, I know that volume equals pi r squared height. Because all my answers have pi in it, I'm just going to put the pi over here to hang out. It's got a radius of 3 squared and a height of 9 over 2. And then I just have to do the multiplication. Well, 3 squared is 9. 9 times 9 over 2 would give me 81 over 2. So I know I'm going to have 81 over 2 pi. This could be an example of a problem that you have to do without a calculator just because those types of multiplication are relatively simple. So as a side note, you'll probably end up seeing something like that. I want to just change my thing real quick. Open up. Okay, cool. Okay, so the answer would be 81 over 2 pi, and that's it. Next. Here, you probably are going to need to have at least 1 or 2 cross-section problems. Think about it again. If the plane in the parallel to the base of the pyramid, which best describes it. Now, here it says a square pyramid. So because it says a square pyramid, you might think it's a square. In this case, they want you to do a rectangle. If it were a trapezoid, it would be like the line cut diagonally down, which I'm not being very good at. If it was a triangle, it would be that they cut straight down the middle and it's like you opened it up. And I don't even know why they put a circle. That's just kind of like a make-believe problem. If I'm going too fast, tell me. I would be happy to slow down. But most of the volume stuff, most people don't have a problem with. Cavalier's principle. I beg of you, please know this. You will absolutely, absolutely, absolutely get a Cavalier's principle. Guaranteed. Basically, Cavalier's principle says if you have two solids, so they can't be hollow, because if you know, like Easter candy, those Easter bunnies, if you break them open, they're hollow sometimes. It's two solids. If every time you do a cross section, even if the shapes are different, if they have the same height, the volumes are the same. So here, this yellow right here, even though it's a square or circle, matches to that yellow square, the areas are the same. This circle right here for the cone or oval, and this for the triangle, because the cross-section areas are the same, that's why we know that we can do this. So it has to be the cross-section areas have to be the same, and also the heights have to be the same. So typically you'll see these words. You'll see the word parallel, cross-section, area, and height. If you see those words, you can pretty much guarantee they're talking about Cavalier's principle. So I was trying to be a little bit funny. So here's my kind of funny picture. Believe it or not, Zoe Saldana and I are both 5 feet, 6.5, 7 inches tall. Obviously, she's wearing heels. And her Gomorrah picture. Very clearly, just because the two of us are the same height, if we were to do some karate chopping of me in half and her in half, our areas around our waist, our hips, our head are going to be different. So because of that, our volume is not the same. It has to be same every time you cut. It's okay if it's a different shape, as long as the area is the same and the height is the same. That's when you're going to have your cross section. Here's a problem that's an example. You might think like, ooh, this cylinder is tilted. Because it's tilted, I can't do this problem. That's not the case. You can do this problem. You can do this problem because the diameter across is 10. The height in both are 12. So I know that because the diameter is 10, area pi r squared, and the height is the same, the formula works for both. So what I'm going to do is I'm just going to do my formula question. Sugar shoots. I've got volume equals pi r squared height. So here it's a trick though. It does give us the diameter. So because the diameter is 10, I know my radius I'm going to use is 5. Now, also, this is not a multiple choice question. So I am going to need to use pi. Usually speaking, they'll tell you to use 3.14. So I'm going to put in 3.14 times my radius, which is 5 squared, times my height, which is 12. And I'm going to leave a break. So if you could get your calculators out, I'm going to get my cell phone calculator out and then type in what you get for your answer. Calculator. Do, 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 do. Do, 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 do. I got it. Do you have it? I'm waiting for someone to type a response. Who's got it? Ooh, we have someone on Remind who got it. Way to go, Shaylin. 942. The only thing is, it will probably have the label for you, but because this is volume, you're going to do 942 meters cubed, because volume, yep, those are all perfect. Excellent. You're going to want to do cubed because it's a three-dimensional shape. So that is it. I'm going to just send out another remind one more time. Excellent. EOC Math Review.com. Okay. All right, you should be getting another remind from me, and I'm done promoting. Okay, excellent job. That's perfectly correct. So again, even though we don't have the exact shape, we can still go on. Here's another thing. I'm going to wait. I want you to read those options and then type in the chat box or on remind what answer you got. Yay, we're getting some D's in. The answer is D. That is correct. It's a trick question for letter C. Okay, so some people put C, and I can completely understand why, because it does mention height. But remember, it's got to be D simply because of the cross-sectional area. As in the picture, Zoe Saldana and I are the same height, but our cross sections are not the same. So because our cross sections are not the same, I have a bigger area around me. My volume is bigger than her volume. So we need to make sure that we look at the height and each of the areas. And then again, remember I told you to look for those trigger words. Okay. Our trigger words are cross-sectional, area, parallel. That's our main thing. Now, technically, it's kind of tricky because it didn't tell you they have the same height. But what you could have done is you could have counted. There's 1, 2, 3, 4, 5, 6, 7, 8 here. Oh, and it tells you the cylinders have the same height. So we can assume same height. What we needed was the cross-section area. And that's where that came into play. Okay. Ooh, my density problem. I don't know where that went. All right, here's the density notes. I don't know why they didn't appear. So for density notes, basically we've got density equals mass times volume. We've talked about it as items. Items over area. Okay, items can be people. Technically speaking, you could also do volume, like in density of that. Like if it's a ring and you want to know the density of the ring, it's items over area. One of my students talked about it's things that can be touched, like people or peach trees or rocks, over space, which typically can't be touched. So however you want to remember that, unfortunately, this is a formula you have to remember. You can remember it whatever way suits you. So let's take a look at an example. This one we're going to do together just because it's a little bizarro. A city has a population of 6,688 people. So we know that we have 6,688 people. And it tells us we've got 7.267 miles squared. And it wants people per square mile. Now, if I was your teacher, I emphasize the word per, like a kitty cat, per. Think of per, that's going to be a really ugly kitty cat, but think of per as a line. So because it says people per square miles, I know my people has to go on the top and my square miles has to go on the bottom. So it tells me 6,688 people, and it tells me 7.267 square miles. That's literally all you do. Then you take out your cell phone calculator or the calculator that they provide you on the EOC assessment, because all of you will never have your calculator next to you when you take your EOC. 6688 divided by 7.267. I get 920. And so the answer is 920. Now, technically, I got 920.32. This is a little tricky. Can you really have 0.32 of a person? So if it's like how many people got on the bus, we would say 920, because you can't have 0.32 people get on the bus. Yes, that's perfect. If you, in this case, you probably would still use the decimal because it's meant as like an approximation. So we could still use the decimal. So that's one thing you want to be a little bit mindful of. Trash. Okay. Exactly. You can't have half of a person. The only reason why I think that they would let you keep it as a decimal is, again, because it's intended to be an approximation. So if you had 10 square miles, you could take that 900 and what was it? Sugar shoots. 920.3. And then if they say how many people live in 10 miles, now you can take, well, 920.3 times 10 square miles tells you that there's 9,203 people. So that's the only reason why I could think about why they would have it be a decimal, is simply because of that. So I want to take a little bit of a break, in the sense that the next thing I want to do next is circles. So I'm going to hold off for 30 seconds. And if you have any more questions about anything I've covered, volume or density, please type it in the box, because I want to address it before I move on. Yeah, we can do another density problem. Let's find one. Do, 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 do. Okay, this one, let me see if I can make it a little bit bigger. Okay, so this says New York City has, let me see if I can see it on my screen to make sure it's big enough. Is that good? Can you see it? Okay. New York City has 8.3 million people and an area of 1,200 kilometers squared. Tokyo has 13 million people and 2,200 kilometers square, which has the greater population density. Okay. Again, we have to remember people over area or property. Excellent. Thank you very much, Ash. So I've got, for New York City, I've got 8.3 million over 2,200, excellent, kilometers. Kilometers. So I'm not going to need to necessarily, I guess I will type all the millions in. Calculator, where did you go? Okay, so I've got 8.3 million. Like, where's my camera? There. And then I'm going to divide that by 2,200. And then I'm going to show you this one, and then I'm going to have you do the next one on your own. So that gave me a value of 3772.7. Then I've got Tokyo, and I'm going to finish demonstrating this one, and then the next one you can do. This one says I had 13.2 mil, but I had 22. Oh, sugar shoots. Did you guys notice what I did wrong? What did I do wrong? Did you see that? My fault. Let's do that one again. So that's going to be 8.3 divided by 1200. Exactly. Good catch. So this gives me 6,916.7. Good job. I'm glad y'all know more than I do. I'm so proud of you. Okay. So 13.2 divided by 2200. Gives me 6,000. So because of that, which one has the greater population density, which means which one has more people? That is going to end up being Tokyo. Oh, New York City. I'm completely out of it. Correct. Okay. So what we're going to do is we're not going to save our progress, but let's look at another question. I'm going to delete this, and this one you guys can try to work on yourselves. I'm going to work on paper, and then we'll see if we get the same answer. So I will read it so we can all see it, because I know not everyone can see it super easily on your cell phones. We've got in a tank of water, a can of regular soda will sink to the bottom, but a can of diet soda will float. I did not know that. Interesting. Then it says that a regular soda, which is about 25 centimeters cubed of sugar, is dissolved in 12 ounces of water with a density of 1.6. The diet soda, actually, you won't get this on your test. We're going to go to another one. Let's look at another density problem, because you don't need to do that one. Let's do one more. That's not going to help me either. Let's see. That's not helpful. Let's look one more time. All right, we'll look at this one. So why don't you work on this one on your own, just to find out what is the density of the substance. So that's the information that they gave you. And then once you know the density, go ahead and plug it in or type it in so we see what we got. Anyone have an answer for this one? It's really basic. The main thing is, do you remember that first formula? If it says the density of a substance with mass of 10 and a volume of 5. Someone says the density of 5. Not quite. Because remember the formula is, density equals mass divided by volume. So if our mass is 10 and we divide it by a volume of 5, 10 divided by 5 is going to give us 2. Yep, that's right. 2 is good. Okay, so just again showing you things that you can touch divided by space. Do we need another density problem or are we good? It's fine. Anyone need another density problem or we can go on? All right, I'm going to go on unless something else comes up. We can always do more at the end. So we'll do more problems at the end if you need it. Let's go on to circle equations. Okay, so circle equations. This is on your formula sheet. So you're going to get this formula. What you won't get is you won't remember necessarily be told how to use it. So as a reminder, when we do circle formula, the formula is x minus h squared plus y minus k squared equals r squared. So what that means is that h and k, I talked about it in my classes, is you want to go home. How do you get back home? So basically, if the formula that they give you is x plus 6 squared plus y minus 3 squared equals 27, in order for you to get the center, you're going to flip the signs, because in order for you to get from a positive to a negative, we know we have to have 2 negatives in a row. So our center would be -6, +3, because we're flipping the signs. If this is negative, it's positive. This is positive, it's negative. Then we have to remember that the radius squared is what the value is. Hold on. So the radius squared is 27. So to get the radius, we know we're going to take the square root. And it's totally fine to get a radical or a decimal as the radius. That's fine. So that's one piece, is remembering to flip the signs whenever you go from the center to the formula to the center, and remembering to take the square root. Next, you probably will need to do something like this, which is when we group the x's, leave a space, group the y's, leave a space. So they've kind of done it already for you here. I'm going to do it again, but a little bit bigger. So let me see. Actually, let me go back to this. Nope. I'm going to use this to write on just so we can see it. If you don't, I'm going to take this really slow. So if you need to write it down, because you will absolutely see this tomorrow. You will see something, or Tuesday, whenever you take your test. If they say something like this, and they ask you for the center and the radius, most of you already know what you need to do. What I taught my students is I said, first, we're going to group the x's, leave a space, group the y's, leave a space. And then this goes to this side. So the opposite of subtracting 8 is adding 8. Once we've done that, then I've told you to set it up, which pretty much just means copy what's on the formula sheet, except don't write any numbers. That's it. So I've got -6, and I want to know, well, in order for me to complete the square, you learned the opposite of b over 2a. Here's an easy way to do it for these problems, because I highly doubt you'll get a coefficient in front of the x or y squared. Just take half. So what we said is we divide this by 2. -6 divided by 2 is -3. And then to go back up, we square it. So -3 squared is going to give you 9. So if we put a 9 over here, we're going to have to put a 9 over here. So I'm going to put +9. Then we do that again for y. +4 divided by 2 gives you +2. +2 squared gives you +4. If I put a 4 here, I need to put a 4 here. Now I still have to add up all these numbers. So I've got 8 plus 9 is 17. 17 plus 4 is 21. So now I've converted it from that long general form to the standard form. Now that it's in the standard form, I can pull out the center and the radius. And I'm going to hold on a second and I'm going to let you tell me what is the center and what is the radius of this circle. I'm sorry. Thank you for telling me I muted myself by accident. Okay, so basically, -3. Okay, so -3 to +3 is we switch the signs. So negative becomes positive. Then +2 goes to -2. And because we switch the signs, and then r squared equals 21. So we have to take the square root to get the radical. I'm going to do one more, but a little bit quicker because I already took it and did it slowly. So let's look at one more, but faster. Mm, I'm debating if I want to give you a fraction, and I don't think they're going to make you do a fraction. Okay, so first we group the x, then we group the y, then we leave a space, and then we do the procedure. So I'm going to work this problem out on paper, and then in about 15 seconds, I'm going to start working it out on the screen. So why don't you go ahead and start working this problem on your own and then see if you get the same answer that I get. Okay. Hopefully, I see one person got that answer. Hopefully, you got a similar answer to that. I'm going to talk through real quick what I did. First, I grouped the X's, left a space, grouped the Y's, left a space. I also moved this 10 to the other side. Then to go down, I divided by 2, got positive 4. 4 squared is 16. Because I wrote 16 here, I had to write 16 over here. Then again, I divided by 2, got negative 4.5, squared it going up. 4.5 negative times a negative is positive. 4.5 squared is 2025. When you add all these up, you're left with 4625. And then finally, we switch the signs to get the center, take the square root to get the radius. And that's it. Can I have a go, no go if I go back and forth? Why do we divide by 2? We divided by 2 because what we're trying to do is what's called completing the square. So, for example, I'm going to erase this and move on so you can see what I'm talking about. Basically, what's happening is when we have this, and you might get this problem also, I'm going to make this easier so I don't have to kill myself. So this is the same thing as saying x plus 4 times x plus 4. So x times x is x squared. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. So here we have 8x. So basically we have 2 4x's, and that's where we had our 4 from here. I really can't explain it more than that today because you don't really need to know why. But you should have learned in algebra, they probably did some kind of square thing like this. And it was like x4, x4, and it wanted to know like what else did you need? And so because there's 2 4x's, we still needed this 16, and that's why we would have added 16 to the other side. That's pretty much the best way that I can explain it. But the reasoning why you shouldn't need, you just have to remember, how do we get to it? We're trying to take x plus 4 and divide it into 2 places. So we divide by 2 to get what goes on the inside, and then we square to get this extra piece that we had to put over here. Okay, I want to move on. So I'm going to delete this. Let's get going. Okay, fundamental things to remember. The center of the circle will always have opposite signs than the equation. I know this is a little bit hard to read. If you have your red books, it's one of the pages, I want to say maybe C3 in the red books. So the center will always have opposite sides in the equation. Let me see if I can make it bigger one more time. Nope. Don't forget to switch the signs. The radius is squared, as we just talked about, so make sure you take the square root first. This part you need to know. So if you don't have this, I would highly recommend you write it down. Basically, what you need to know is that if you are given the center, ooh, that's pretty, and a point, you're going to use the distance formula to find the radius. So if you're given the center of the circle and a point on the circle, you're going to use distance formula to find that radius. If you're given the diameter of the circle, you're going to use the midpoint formula to find the center. And then you're going to use the distance formula to find the length of the radius. Now, sometimes what I do is sometimes I'll find the diameter and then divide the diameter by 2 to get the radius. And the only time I do that is if I'm not confident in my center. But that's what this one says. Don't forget, midpoint formula is you're finding the average of the 2 points. So you add the x's, divide by 2, add the y's, divide by 2. If you're given the radius, the center, and a point, you're going to use the distance formula to compare the radii. Whichever has the bigger radius is the one that's farther away. And then to find an equation of a tangent, which you're going to, I don't know if you need to know this, but you're going to find the slope of the radius, and then you'll do opposite reciprocal to get the new slope, and then plug it into y equals mx plus b. I went over that fast. I'm not confident you're going to see it, but we'll have some problems to look at next. Okay, so here we've got the center of this equation. Why don't we, guys, you can use distance formula to find the diameter for sure, and then I typically divide that by 2 to get the radius. Here, we're going to just plug this in. I'm going a little fast on this one because I think we've already pretty much talked about circles a lot. And I'm doing 4 squared because I know it's the radius is 2. So it's got to be 4. All I did was I made sure I switched the signs. Sure shoots. Next, here's one that we just worked on. So again, they give us the center, they give us the radius. Now we have to see how it fits in. This is similar to what I was showing you the reverse way. So I'm going to go over this. First, I'm going to start off by putting this into the equation. So I know I have to switch the signs. Now you have to do binomial multiplication to expand this out. And what I mean by a binomial multiplication is similar to what I just showed you. Some of your teachers taught you this way. X times x is x squared, 2x, 2x, 4. So I don't know how your teacher taught you to do binomial multiplication, but that is basically what you're going to do. So here, I know this is going to equal x squared plus 4x plus 4. When I do this one out, you're going to get y squared minus 6y plus 9. And then basically the reason why you got that is you could do this method right here, but you also might do it this way, which is how I typically teach students to do it, which is the FOIL method. Some people call it FOIL. It's actually binomial multiplication. And then now we just combine like terms. So I've got x squared. Well, we put it in the correct formula. So x squared plus y squared. Then I do my x again. Then I put in my y. And this is where it gets tricky. I've got positive 4 and positive 9. But see how all of these answers equal 0? So once I combine 9 plus 4 and get 13, I have to remember that I have this 13, but I have this 9, so I have to subtract 9. So when we subtract 9 from both sides, that's going to get us 4. So it's going to be choice C. So some of the problems will be quick. This one is going to take longer, but pretty much all they're testing you on is, do you know how to flip the signs to bring it over? That's basically what they're testing you on. Here's another one. This one I'm going to work through a little bit faster. So I'm going to group my x's, leave a space, group my y's. There is no y. And then this gets moved to the other side by adding 11. So then I divide by 2, square it. Then I divide by 2 again. 0 divided by 2 is still 0. So this is going to stay y squared. Nothing will be added on. All that equals 36. Switch the signs. The opposite of -5 is +5. This will be 0, and that's my center. If they wanted my radius, it would be the square root of 36, which is 6. Or flamingo, because that looks like a flamingo. Okay, I think we've finally gotten through all the circle problems. Are you okay moving on? Can I have thumbs up to move on from circles? When do you leave the signs? I don't think you ever leave the signs because the formula says x minus h, so you have to change the signs. That one, I'm honestly not sure what you're asking, girl. Okay, let's move on. And then if we can address your question specifically later. Okay, so let's talk slope. So after most people are done, then we can go on. Okay, so here we've got, yes, sine, cosine, tangent, inverse will be on the test. That's coming up shortly. Okay, here we've got slope formula. For slope formula, you will have to memorize the slope formula. They're not going to give it to you. This is the slope formula. You probably also know it as rise over run. Okay. Remember, positive slopes go up, negative slopes go down, zero slopes stay the same, and vertical slope or undefined is like straight down. Whoosh. So let's look at a more challenging question. For what values of n are the lines 7x plus 3y equals 8 and that nx plus 3y equals 8 perpendicular? Okay, so I'm going to show you the surefire way. There is a shortcut, but I don't want to stress people out with the shortcut. So the first thing I've got is 7x plus 3y equals 8. I'm trying to get it into that y equals mx plus b mode. That's what we're striving for. So what I'm going to do is I have to get y by itself. So I'm going to subtract 7x from both sides. This gets canceled. I'm left with 3y equals negative 7x plus 8. And then I divide everything by 3 so I can isolate the y. And my first equation is this. Negative 7/3 x plus 8/3 y. So my slope here is negative 7/3. And I know it's my slope because whatever number comes before the x is my slope. And negative 7/3 is the coefficient to the x. Here, I need to do the same thing. So I'm still going to put nx, subtract nx from both sides. I want to make this a little bit smaller, Jazz. So this is going to give me 3y equals negative nx plus 8. Divide everything by 3. And I'm left with y equals negative n over 3 x plus 8. Now, if they said parallel, we know that parallel lines have the same slope. They said perpendicular, and perpendicular slopes are opposite reciprocals. So basically, here I have negative 7/3, but I need the perpendicular slope. So the opposite reciprocal to negative 7/3 is positive 3/7. So we need negative n over 3 to somehow equal positive 3/7. So all we're going to do is set up a proportion. And now I'm going to start erasing so I have space. What we're going to do is we know that the opposite reciprocal slope that I need is 3/7. What we have is negative n over 3. So what we have to do is figure out, okay, what value can we get for n that's going to make it equal? So all we're going to do is cross multiply. Negative 7n equals 9. N equals negative 9/7. And that's it. Now, I would be significantly surprised if you see a question with this much detail on your test. Oh, thank you, dear. I think we're good, but I might go back to the middle font because if you can you still see that? The blue circle? But anyway, but you will get other formulas. So I can't imagine, you might not get one that has n, but you will have to remember to do y equals mx plus b. And you'll have to remember to do parallel, same slope, perpendicular, different slopes. Next. This is going to be on your test. This is an easy question. Isn't the 7a negative? Isn't the 7 a negative? I move the negative to the top because fractions should always have negatives in the top. And it's not a negative here because my original slope was negative 7/3, and the opposite of negative 7/3 is positive 3/7. So that's why the negative stays there. So yes, this could be a negative down here, but if this was a negative down here, then that would be a positive, and still a positive divided by a negative is a negative. So that's why proper math is we put the negative in the numerator. Okay, here we've got directed line segment. They give us the points, and it tells us the ratio is 1 to 3. We know that A has to equal 1, B has to equal 3. It might also help you to label this x1, y1, x2, y2. On the formula sheet, if you see the word, I'm sorry, sugar shoots. On your test, if you see the word partitions, you are most likely going to use the formula that's on the formula sheet. That formula is bx1 plus ax2 divided by b plus a. That will just give you the x coordinate. You have to do that again for the y coordinates, the same equation but with y's. So I'm going to put in b, which is 3, times my x1, which is -1, plus a, which is 1, times my x2, which is 7, and divide that by 1 plus 3. If you're in my class, I taught you how to go up and down. So I would say 3 times -1 is -3. -3 plus 7 is going to give you +4. 1 plus 3 is 4. So 4 divided by 4 is 1. So I know my first coordinate is 1. Now I do the same thing again, but this time with the y's. So I've got 3 times y1, which is 2, plus 1 times y2, which is 8, divided by, we already know adding them up. Well, I'll just write it. 1 plus 3 is 4. Here we've got 6 plus 8. That's 14 divided by 4. 2.5. No, 3.5. What am I thinking? 3.5. And that makes sense. That's where the debt would be. 3.5. So this was to figure out the y. This was to figure out the x. I don't think I'm going to do another one of these problems. The main thing I want you to remember for these problems is if you see the word partitions, it's probably the formula sheet. What you do need to know is that the order of the letters matter. Whatever one they give you first, that's going to be your first coordinate for the formula. Whatever they give you second, that's going to be your second coordinate for the formula. Also, when they give you a ratio, you're going to use the ratio for the A and the B. Now, there's only one thing that's different. If they told you that they wanted a point Pretend this is not there. So I'm going to take this off. Pretend instead of saying the ratio of 1 to 3, they said 1/3 the way down. And they gave it to you as a fraction. They did not use the word ratio. So the word ratio wasn't on the problem. If that is the case, you have to think, okay, if I have something that's 1/3 of the way down, it would be marked right here. Well, that means there's one part here and there's two parts here. So my ratio would be 1 to 2. You will only do that if they give it to you as a fraction. I would be surprised if you get it as a fraction on the EOC. I do expect you probably will get it as a fraction on the district assessment because they like to be like that. But I would think that on the EOC, you would not have it as a fraction. Here it wants us to find the area of the rectangle with these vertices. I'm going to do this a little bit differently than you know how to do it because I like to, it's 5:20. Are you guys ready for a 5-minute break? Okay. Most people say keep going, so let's keep going. Here we've got if you need a break, you can always watch this couple of minutes later. Okay, so here once area of a rectangle. You can plot the points if you want. I'm just going to do distance formula. So let's take a look. It tells us the rectangle ABCD. Remember, just sketch a rectangle. Because it wants ABCD, we know that in order for us to find the area, you need to do length times width. So that means that here's my length, here's my width. So I need to find AB and I need to find BC. Now, I could also find BC and CD, but that's kind of what we're looking at. Okay. So I'm going to do the distance formula the way that I like to do it. Their long way that you can do it on the test and it's on the formula sheet is x1 minus x2 squared plus y1 minus y2 squared. You also could use the graph paper. Remember, you have to ask for graph paper, but you could also use the graph paper, raise your hand, plot the points, and count the boxes for the rise and the run and use Pythagorean theorem. I'm going to do it the way I like to do it because I just like to do it my way. So first, how my way goes is I'm going to write an A and a B. My A is -3, 0. My B is +3, 2. My way is you subtract the bottom row. So I'm going to subtract this and subtract that. So I've got -3 minus 3. That's going to give me -6. 0 minus -2 is going to give me -2. Essentially, all I did was each of these parts. I subtracted my x's. I subtracted my y's. Now I have to square both of these and add them together. I've got 36 plus 4, which is going to give me the square root of 40. So AB equals the square root of 40. Let me show you my method one more time. It wants BC. I'm going to write down B, which is 3, 2. I'm going to write down C, which is 4, -1. We know we have to subtract, so I'm going to put the subtraction signs. 3, +3 minus 4 gives me -1 squared. A minus makes this a plus. 1 squared plus 9. So 1 plus 9 equals 10. So I've got the square root of 10. Now, this is a trick. It wants you to find the area, so make sure you find the area. Don't find the perimeter. It wants the area. We know the area is length times width. So I'm going to just know, well, the square root of 40 times the square root of 10 is the square root, hopefully remember this, of 40 times 10. 40 times 10 is 400. So when we take the square root of 400, you're going to get 20. So let me talk about that again, but with the highlighter tool. I know it wants the area. So because it wants the area, I know I had to find what's the length, what's the width. In order to find the length, I found the distance formula to get AB. I did my little tricky way, but basically it's the distance formula to find AB. That told me this length. Then I did the distance formula again to get BC. Now, of course, this is not drawn perfectly because this is a sketch. If I have any prayer for you or beg of you is please, please, please draw as many pictures as you can tomorrow. You can always ask for more scrap paper. If you ask for it, they will give it to you. Nonetheless, I found the square root of 40 for AB and the square root of 10. Now, technically speaking, you can put in the calculator the square root of 40 times the square root of 10. Unfortunately, these two numbers are not perfect squares, so you would end up getting a decimal. That's why it's best practice to just multiply the insides first. 40 times 10 gave me 400. And then once you've done the multiplication, take the final square root. Okay. Which information is needed to show that a parallelogram is a rectangle? If you have the papers I sent you, I highly, highly recommend, I put it out on Remind. I highly recommend, where's my Remind tab, Michelle? Right? Nope. Here it is. So I highly recommend that these things right here that I sent out on Remind, that you will please, please, please know this. Sure, I can do it again. First of all, basically what we need to know is we need to know the distance formula. So this time I'll do it the distance formula way. So I know I need to find, if I draw a shape, I'm intentionally putting A, B, C, D in different orders. I know I need to find AB and CD. To find AB, this is going to be my x1, y1, x2, y2. The distance formula says x1 minus x2 squared. This is on the formula sheet. Y1 minus y2 squared. So I'm going to put in x1 is -3 minus x2, which is +3, squared. Sugar shoots squared plus 0 minus 2 squared. So here, did I do that right? All of a sudden I'm doubting myself. -3 minus 3, 0 minus 2. Yep. Then here I've got -3 minus 3 is -6 squared plus -2 squared. 36 plus 4, the square root of 40. So that gave us AB using the official distance formula. I'm going to do the same thing to find BC because BC is the other side I need to multiply by. So I'm going to do BC is what I need. So I'm going to do 3 minus 4 squared plus 2 minus -1 squared. 3 minus 4 is -1 squared. Do you do the same way if you ask for perpendicular? No. You asking for perpendicular is slope formula and doing the opposite reciprocal. You will do it this way if they need to know the distance of something, the length of something, how long is the diameter to find the radius. What else? That's pretty much when you use it. Oh, when you're comparing radius, like is the point in, on, or outside the circle? This is the long form that you would use for that. These become plus. Negative times a negative is positive. So now I've got my two pieces. I know that this side here is the square root of 40, and this side here is the square root of 10. Because we have to do length times width, I'm going to take the square root of 40 and multiply it by the square root of 10. You should have learned radical rules, which means that you can put those two underneath the same radical sign. That gives us the square root of 400, When you take the square root of 4 sugar shoots, when you take the square root of 400, you'll get plain 20, because 20 times 20 is 400. So most of you will probably do it this way. Unless you had me as a teacher, you probably will do the shortcut for distance formula. Either way, you'll get the same answer. This way just takes longer. There's 2 sections of the test, excuse me. Each section is 85 minutes long. You have to do the whole thing by 10:30, but you're allowed to use the whole 85 minutes. Some people might get done. You have to take at least 60 minutes, but no one can move on until everyone's done. So you can take the whole 85 minutes if you want. And if you're one of my students, you gosh darn better take all 85 minutes. You don't want me to kick you in the associative property. Love you. Okay. Moving on. Parallelogram is a rectangle. Again, this is something that you're going to have to pay attention to. There's some on here, parallelogram facts. And I think that's the only place I had stuff on parallelograms on the crazy quick review, because I didn't expect a lot of it. By definition, diagonals bisect each other. That's for all parallelograms. It's not just for rectangles, so it's not A. Diagonals are congruent. That is just for rectangles, so that's the correct answer. That's because, why is that? Oh, like a paper airplane. When you fold it on the diagonal, those measures are the same. Diagonals are congruent and perpendicular. That gives you a square. And then diagonals bisect each other and perpendicular. That gives you a rhombus. So you're just going to have to know the facts. That's pretty much it. Okay. Next. At which point is on a circle with a center of 3, -9, and a radius of 5? Oh, it was B. The diagonals are congruent. For it to be D, it would have to be a rhombus, because, diagonals bisect each other. Yep, perpendicular. It's a rhombus for D, because a rhombus is, it has the 4 sides that are the same, and they form right angles. But the diagonals aren't the same, because clearly this line here is longer than this line. So that's why this is a rhombus. This is a square, because in a square, pretending I did it correctly, these diagonals are going to be the same because it's a rectangle, and it's going to be right angles because a square is also a rhombus. Here again on outside, so we're going to use the distance formula. They were generous. They told us the original one had a radius of 5. So we're going to see which one of these, when we use this point, is going to give us a radius of 5. Now, I'm a little bit lazy, so this is my trick. See how this says 5? Well, we always know the way that we get the radius is we take the square root. Now, the opposite of addition is subtraction. The opposite of multiplication is division. The opposite of taking the square is the square root. So the opposite of taking the square root is taking the square. So I know that the radius squared is 25. So I'm pretty much just going to do distance formula and see if I can get 25 out of these. What I mean by that is -6 and 5. Here's the center they gave me. 3 and -9. Well, I know I have to subtract the x, subtract the y's. -6 minus 3 is -9. Actually, you know what? I'm going to be nice. I'm going to do it the long way, just so you guys don't get confused. Okay, so I'm going to subtract the x's, subtract the y's. This is going to give me -6 minus 3 is -9 squared. Plus, this becomes addition. 5 and 9 is 14 squared. Now, remember, I'm hoping that all of this ends up equaling 25. So this gives me 81 plus 196, which is the square root of 277. Obviously, the square root of 277 is much bigger than 25. Okay, 277 is bigger than 5. or sugar shoots, or 25. So in this case, this one is not the correct answer because that point is outside the circle. So then we have to do this whole thing all over again for the next point. So I've got radical, subtract the x's, subtract the y's. Again, this is going to give me 15 squared just right here. 15 squared is 225, and I'm going to be adding it. 225 is bigger than 25, so I can stop. That's also going to be outside the circle. Next. Here, I've got 1 and 6. So I'm going to start off by doing it again. I've got, yes, that is the distance formula. We use the distance formula for length. So we've got 1 minus 3 squared plus 6 minus -9. Again, that's going to cause it to be 15 squared. So again, that's not going to be right. Notice how all of these y's make you make it get bigger. So it's not C. So the answer is choice D, and I'll show you why and do it the whole way. So we've got sugar shoots. That's really big. Subtract the x's, 6 minus 3 squared. Subtract the y's, -5 minus -9 squared. Those become addition. It's cool. I know you. So that gives me 6 minus 3 is 3 squared. Plus, this gives you 4 squared. That gives you 9 plus 16, which gives you 25. The square root of 25 is 5. So this is the correct answer. It is a pain in the tushy, and I'm sorry. That problem took us like 5 minutes, and you will probably see a problem on your test like that. So just keep persevering. Distance formula, one step at a time, distance formula. Okay, we're still on equations and measurement. I'm ready to get off of equations and measurement. Oh, we have one more question, then we can move on. Praise God. Okay, here we've got last one, which is the equation that is perpendicular and passes through. Okay, here's the line they give you. This slope is -1/2. We know it's -1/2 because -1/2 comes before the x. It says perpendicular, so I'm going to do the opposite reciprocal slope. So my perpendicular slope is going to be 2. Not x, just 2. Negative becomes positive, flip the fraction. Opposite, reciprocal. So I know I can eliminate choice A and choice B. It has to pass through the point -4, 0. So all you're going to do is take each one of these options and plug in -4 and 0 and see which one works. This gives you -8 minus 2. So you're left with -10. -10 does not equal 0, so it's not choice C. It's got to be choice D. That one I'm not going to do again because I have a lot of videos on it. This one, please, please, please remember all circles are similar. All circles are similar because of the relationship between the ratio of the diameter to the circle, because all circles have pi in it. So all circles are similar. Please make sure you remember that. I logged out of Remind for some reason. I don't know why. Okay, all circles are similar. Again, don't just say it was a dilation. You'd have to say why. If it goes A to B, we know that this is 2, this is 3. Our scale factor is the new over the old. So you want to make sure you do that. Next. Probability. A couple things that I went through too quickly on Thursday. Please make sure you remember to use these formulas. Literally, if I ask you, like, for every single probability question, just look at the formula sheet to make sure you don't need to use it, because you might need to. If you see or, you're going to have to remember to add the probabilities and subtract the overlap. If you see the word given, that's for the top one, given. And if you see relationships, that's when you're going to do the middle one. So please pay attention to the probability formulas. 15% of your test is on that. So that means like 8 to 10 questions. Don't forget for complement, complement is everything else. So it's like, this is what's in A, what's not in A. What's not in A is everything else. Mutually exclusive means that there's no overlap at all. Okay. I live in Florida. I don't know where someone else lives somewhere else. I don't live in Florida anyway. I live in Georgia. But nonetheless, my aunt lives in Florida. I live in Georgia. There's no overlap. 2 different states. There it works. Union is everything they have in common. This is Brichenet's tip. I don't know if she's still on, but she taught me that this U, well, U is kind of like an O for or. So if it says like A union B, it means it wants A or B. So you can think of it like that. Just don't forget, if they say or, you need to make sure you subtract the middle piece that overlaps because you don't want to count it twice. Intersection is like A and B. She does it like this. She makes it, thinks of this as an N. So Brichenet's tip is like and, like that. I think of it kind of working on her tip as I make this into an A. So, it's A and. Also independent, if when you multiply the 2 individual probabilities together, you get the intersection of them, then you know that it is independent. So let's take a look. This is one we did already on Thursday, but I just want to reiterate it. All you do is you multiply. On the formula sheet, it tells you if you multiply, that's what it says. So if I take my trusty cell phone calculator out and I type in 0.25 times 0.25, I get 0.625. Ooh, where are we? There it is. Because it says 0.625, I know that 0.625 is what I get when I multiply those together. 0.5 does not equal 0.0625. So because of that, it's not choice A. I do the same thing again for choice B. 0.08 times 0.4. I get 0.032. It does not equal 0.12, so I know it's not choice B. Those things are still related to each other, independent and dependent. 0.6 times 0.24. Again, I multiply. Look it, you think it's pretty gosh darn close. I see the 3, 2. It's a trick, but alas, again, they're not equivalent. 0.3 times 0.15. That's what we want. Those numbers are the same. So the formula on the formula sheet worked. Therefore, they are independent. It literally is that simple. If it asks you if something is independent, all you do is multiply. That's it. Multiply. Next. Here it mentions assume that they're independent. So we're not doing the independent formula where we multiply anything together. We're looking at this magical word that is given. Give. It's such an easy problem. They're giving you something. Okay. Given says, first of all, remember all probabilities have to be less than 1. That's the rule. All probabilities have to be less than 100% or less than 1. So if you took your calculator and went 0.72 divided by 0.46, you would get a number bigger than 1. So that's wrong. On the formula sheet, it says that you take whatever they have in common, 0.46. Technically on the formula sheet, it looks like this. What they have in common, and you divide it by whatever the given is. In this case, the given is 0.72. That's the whole problem. That's literally all you're doing. 0.46 divided by 0.72, done. 0.638, which is choice D. So 2 of those problems. 1, if you're looking for independence, you multiply the 2 numbers together. 2, if they say given, you're going to be dividing, period. Too bad Tati's not on here because she'd be like, period. Next. I know I'm going through this, but you're going to have 8 to 10 questions, and I think probability is one of the easier topics. That's why we're looking at it. Here it says, again, it says given, sugar shoots. Given that one person is male. So the only people we care about are people who are male. That's it. That's the only people we care about. Of that, it wants to know, what is the probability a randomly selected person is blonde? What we do is we just look at for the overlap. We know that there's 876 people who are blonde and male, and there's 1,506 total males who were surveyed. So again, what's the overlap? 876 divided by 1,506.58. Done. It's that simple. It says given, so we know we're looking at a select group of people. And we know we're dividing. Let's look. I think there's one more. Ooh, there's not. That's it. Okay, I'm going to move on from probability. Special angles. Things to remember. A tangent is perpendicular to a radius. Why is this important? They'll probably have something like this, and they might give you this angle measure. They want you to find this angle measure, or they'll give you a value here, and they want you to find Pythagorean theorem. Any of those ways is why that piece of information is important. An angle that's inscribed a semicircle always equals 90. Basically, it means that it touches the diameter. We know a diameter is 180, and then 180 divided by 2 gives you 90. Anytime you have a shape that's inside the circle, the opposite angles are supplementary. Supplementary means that they equal 180 degrees. Next, again, tangent to a radius. Here's this shape. You'll probably see a problem like this. Pretend I can draw better. They might tell you this is 10, this is 6, and then this is 4, and they want to know the perimeter or side. Well, if this is 6, that means this is 6, which means this is 4, which means this is 4, which means this is 4. And basically all it's doing is saying, well, these two pieces match up because tangents from the same point are congruent. These two match up because tangents from the same point are congruent. And then you answer whatever question they ask you from that. I went fast on purpose on that one because I've talked about it a lot. Don't forget segment relationships. If you have segments that intersect, I don't know how to make that bigger. Part times part equals part times part. If you have parallel chords, the intersecting pieces are the same. It makes sense. Just look at it. If you have congruent chords, the intersecting arcs are the same. Here, if you have a radius that forms a right angle with a chord, then you know you've split it. It's the perpendicular bisector. And then here we've talked about is outside times whole equals outside times whole. Area of a sector we talked about on Thursday is like the pie of the pie filling, the cherry pieces. The outside crust is the arc length. Okay. Next. Okay. In this circle, AB is tangent to the circle at point B. AC is tangent at point C. Point D lies on the circle. What is the value? We did do this one, but I want to do it again. Because it's tangent, we know that this is 90 and this is 90. And we know that because tangent to a radius equals 90 degrees. If this is 48 degrees, we know that this arc to angle, you would multiply by 2. This arc right here is 96. If that arc is 96, then we know this central angle is 96 because central angle, center, same. Now we're going to look at 90, 96, and 90 to get this missing angle. And we know that there's 360 degrees in a quadrilateral. Well, subtract 180 gives you 180 left. Subtract 96 gives you 84 degrees. And I subtracted 180 because 90 plus 90 is 180. So sometimes you just have to work through problems step by step. Here's another one we did already. Here's the diameter of the circle. So they're making sure that you know a diameter is 180. If this is 180, that means this is, and they give you 120, that means 60 degrees is left for here. 96 came from 48 times 2. The inscribed angle to the arc is arc to angle we divide by 2. Angle to arc we multiply by 2. So since we were given the angle measure of 48 degrees for the inscribed angle, here, since this was 48, right here, sugar shoots. This angle is 48. To get this arc right here, 48 times 2 is 96. And then because that's a central angle, here, angle O is a central angle. This angle here has to be 96 as well because central angles are the same. So if that's 96 and these two are 90, we subtract to get the missing value. Okay, back to this problem. So we know that this is 60. We're going from the arc to the angle. Think of the ice cream cone. That leaves 30 degrees left for ABC. Okay. Next. Here it says the length. Just again, I'm not going to do this problem, but remember, arc length and area of a sector are on the formula sheet. All of these answers have pi in them, so you are not going to type pi in. Also pay attention, here's this arc they're talking about. That's not always the case. Sometimes like this, the arc that they're talking about is this whole area here, so we need this angle measure. So you would have to subtract from 360 to get the missing angle here for theta. Again, all of these answer choices have pi, so you're not going to type pi into the calculator. Transformations. Remember, these three things are isometries. Because they're isometries, okay, we know that they're congruent. And we know they have rigid motion. So whatever happens, we know that congruence is preserved. The only transformation congruence is not preserved is dilation. Also, remember, if you're reflecting over a diagonal line, you always need to find perpendicular. This is always going to be the perpendicular bisector. So like here, there's 1.5. Here's there's 1.5. Here's the right angle. Here, there's 2.5. Here's 2.5. Here's the right angle. Here's a half. Here's a half. There's the right angle. So you always will go on the right angle whenever you do the reflections. Translations, remember we add or subtract, those are shifting. Dilations can get bigger or smaller. So be careful when you see questions that say always, because it might end up having it be bigger or smaller. So we just have to be a little bit careful on that. Let's see. Also, to find the center of dilation, I kind of gave you this picture here to help you visualize it. You just connect the matching points, and wherever they touch, that's your center. So here we connect BB prime, AA prime, DD prime, CC prime. There's our center of dilation. Same thing here. This one goes down, this one goes down, this one goes over, center of dilation. Center of dilation, we just draw lines. That's it. Okay, here, which statement's always true? Again, because of the word always, we did this problem already. It doesn't here, it's equal. That doesn't make sense. That would be a dilation of 1. Here it says greater. That doesn't make sense because the shape could shrink. Here again, it says greater. Again, that could shrink. And this is it. The ratio of the diameter to the circumference is the same because all circles are similar. You guys are doing great. We're almost done. These are going to go quicker. This one you've seen. The main thing I needed you to know is whenever you do dilations, I want you to remember sides are proportional No. Angles are always the same. This is angles, same. Excuse me. So that dilation factor is just there to confuse you. That's it. The dilation has nothing to do with angle measures. The angle measures will always stay the same because of similarity. Okay. Congruence is preserved for rigid motion. Similarity is preserved for dilations. Here, I just wanted to show you this one more time, just in case you get a problem like this. There's something, side splitter theorem, which means that if you have a parallel line that cuts a triangle, it cuts the pieces proportionally. So in this case, we'd have x over 3 equals 6 over 4, and then we just cross multiply. This I am going faster on. If you need me to slow down or go back, I can. But I know that there's other videos that go over these exact problems because this is the review from Thursday. I just wanted to show it to you one more time. Here is mid-segment. Remember, for mid-segment, you get parallel lines. And I told you to look for the hidden parallelograms. So whatever value this is here, it has to be down here. Whatever value this is here, it has to be here. So look for the parallel sides. Look for the parallelogram hidden inside. For mid-segment theorem, it says it's pretty much half. So if this is 5 here. And then if I do my parallelogram this way, if this is 5, this also has to be 5 here. So that's why it's 2 pieces equals the 1. That was too fast. Let me show you again. Okay, let's say they want to know what's the perimeter of this triangle. So because this piece right here is 9, and this is the parallel side, I know that this piece has to be 9 because of this right there, parallelogram. And I know this has to be 9 because of the parallelogram that goes that way. So because of that, I know those pieces are 9. The same is true over here. Here, if this is 8, each of these pieces also have to be 8 for the same reason. And this piece is 7, so that means this piece has to be 7, and this piece has to be 7. What they might do is they might trick you, and they might ask you for the trapezoid shape inside. So maybe they'd ask you for this trapezoid shape inside. So then what you're going to do is you're going to see, okay, what pieces does it touch? Sugar shoots, that's really big. It touches this piece, 7, this piece, plus 7, this piece here, plus 9, this piece here, plus 7, and this piece here, plus 8. And now I know what I need to add up. So you've got 21, 30, 38. So if they asked you for like, what's the perimeter of the interior trapezoid, that's kind of what you're going to do. But that's what the mid-segment theorem is. It says that if you have 2 lines that are parallel, that it ends up joining the midpoints, then you can come up with those ratios and relationships. Okay, a couple things just picture-wise. Please remember this picture is angle bisector. Because it's angle bisector, that means each of these inside pieces are the same measure, and both of them added up equals the whole. Here, perpendicular bisector. That means that couple things. One of the main things that it means is that this side here and this side here are equivalent. There's another secret thing that it means. And what it means is if I draw a line from here to here, those red lines are going to be the same. If I draw it from here to here, those green lines are going to be the same. Basically, because these are right angles and these heights are the same and these are the same, basically it's like a hidden Pythagorean theorem. But you might get asked something like that. So for perpendicular bisector, please remember how it's drawn, but also remember that those connecting segments are the same. Again, here's another example of perpendicular bisector. Here's an example of a construction question. Again, if you have the diameter of a circle, you would draw the perpendicular bisector. That's how you could get the square, because when I draw the perpendicular bisector like this and connect my dots, I now have my inscribed square. So that's how you do that. If you have to do like a hexagon, what I taught you is you need to know the radius. You use the compass, find the radius, pick a point, and then move that radius point all the way around, and then connect the dots. And that's how you get the hexagon. I don't know, random piece of information. I don't know why that came on my head, but it did. So in case you see that, that's what happens. Trig, Pythagorean theorem. Yay, we're almost done. Okay. Anytime you have two legs, if there is no mention of an angle at all, you will never, ever do sine, cosine, or tangent. You will have to do the Pythagorean theorem. I wasn't going to have us do proofs because I already have a ton of stuff on proofs, but I can pull stuff up on proofs after we're done with this if people need me to. Okay, so Pythagorean theorem, leg A, leg B, hypotenuse. There's no mention of angles, so I'm not going to do sine, cosine, and tangent. What are the angle relationships? The angle relationships are theta is the angle you're talking about. With theta being the angle that you talk about, right here, we talked about the hypotenuse is always opposite the right angle. The adjacent always touches the angle. Then the other side is the opposite side. Okay. Okay, here, theta is the angle that you're talking about. We use trig ratios to either find missing angles or missing sides. If we're given an angle and a side, we're going to use the trig ratios all by itself to do sides. Okay. Woohoo! I guess we're doing... Okay, so we need to use the sides. We use the ratios. If we need an angle, we use the inverse function. Remember in what I showed you at the beginning of this presentation, when you use the inverse function, you're going to have to hit the second button. So this is an example of a question they probably will give you before you get to use the calculator because, oh no, never mind. This is not a calculator question. And Izzy, I expect will be done way before 7 o'clock. But if it goes later, it goes later. I budgeted myself till 8 o'clock just in case. Okay. So here because they give you the trig identities or the trig values, and it's kind of a little bit complex. This is one that you probably will need to use the calculator for. So let's take a look at it. Ricardo is standing 75 feet away from the base of a building. The angle of elevation from the ground is 32 degrees. So let's go ahead and start labeling this baby. 32 degrees is the angle we're talking about. Because they already give us the angle, we're not going to do inverse. The only time that we do inverse is when we don't have the angle. So that's our theta. So right here is our right angle. This makes this the hypotenuse. The hypotenuse and the angle touch the adjacent side. This is our opposite. So right away, we've got x hypotenuse or x opposite and a 75. Those are the two things we know. We know opposite and adjacent. Well, if I look down here, I know it's kind of small on the cell phones. Sine is opposite hypotenuse. Let me make that bigger for you. So we have sine equals opposite hypotenuse. Cosine equals adjacent hypotenuse. Tangent equals opposite adjacent. So we've got here opposite, but we don't have anything for the hypotenuse, so it can't be sine. Here we've got adjacent, but again, we have nothing for the hypotenuse, so it can't be sine. So now we're left with opposite, adjacent, so it's got to be tan. So we know we're going to use tangent. Now we just plug it in. We've got tan 32. That's not helpful. We know we've got tan 32. Be nice. This is being recorded. Equals opposite x over adjacent, which is 75. They gave us the values. So what we're going to do is we're going to take this and just go tan 72. They told it was 0.6249. We're going to multiply that by 75 because I'm just cross multiplying and I get 46.865. And it wants it to the nearest tenth. This is an example of when you need to make sure you remember how to round from back in the day. Because it wants the tenths place, this is the tenths place. So I look at the place next to it, which is the hundredths. This number, if it's 5 or more, it means this number will go up. If this number is 4 or less, then it stays the same. This is a 6, so it goes up. My answer is 46.9. We're going to do some more tricks. I'm going to keep going. Here's another one. Again, they tell us here's our angle. So because we have the angle measure, we have our theta, but we are not using inverse because we have the angle already. Here's our 3 degrees. They might not always tell you that that piece is going to be 3 degrees. You would just have to know it, sugar shoots, because parallel lines, alternate interior angles. But just in case, here they did. This is our theta. Here's our right angle, which makes this my hypotenuse. This makes this the adjacent, and this is my opposite. So then I've got something for opposite and something for hypotenuse. So opposite hypotenuse gives me sine. So I know I'm going to use, sugar shoots, that's not helpful. I know I'm using sine. So I've got sine of 3 equals 3 degrees equals my opposite over hypotenuse. Well, the sine of 3 is 0.0523. That's going to equal my opposite side, which is 5,900 divided by my x. Cross multiply, I'm going to make it extra long. So this is going to be 0.0523 times x equals 5,900. Now we're going to divide everything by 0.0523 and then get our answer. So sometimes you have to do 2 steps. You might have already known to divide. I did teach you guys that trick in December, but in case you didn't forget, in case you forgot and didn't remember, you can also do it the longhand way, which is the way I showed you. When you do, we get this value. X equals, it doesn't tell you how to round. So I'm just going to round to the nearest foot. They will always tell you how to round. So don't feel like you need to know that. But in this case, from where I grabbed it, they didn't. Okay, this is an example of one that you could see in the no calculator section. It tells us what is the best approximation of C. So we know C is our theta. Because C is our theta, here is our right angle, which makes this the hypotenuse. This is the opposite. This is the adjacent because it touches the angle and it's not the hypotenuse. We know the value we're shooting for is 0.923. So this is really, confused about which one, the other one or this one. So what we're going to do is we have to see, okay, if we plug those numbers in, which is going to give us a number close to 0.923. So if we look at sine first, we know sine is opposite hypotenuse. So we know sine equals opposite hypotenuse. So I'm going to say, does 0.923 equal 5 over 13? Well, I know that 6 over 12 equals 0.5. So 0.5 is relatively farther away than 0.293 or 0.923. So for that case, I know it's not going to be, I know it's not going to be sine. because 0.5 is too far away from 0.293. Remember, we're approximating. It's not exact. The next one says cos 0.923. Cos is adjacent over hypotenuse. So my adjacent is 12 and my hypotenuse is 13. Well, I know 13 over 13 is close to 1. And so for that case, I know that it's going to be cosine. Yes, I can. I think I thought I had an inverse in here. Okay. Let's go back to the other one first. And let me also pull up. I don't know what you are. We'll go back. Images. Okay, we'll do inverse on that one. Let's go revisit this problem real quick. This problem again wants us to find x. Okay, so when we find x, what we're going to do is first, let's label what we know. Well, we know this is our theta. If this is our theta and here's our right angle, x is our hypotenuse, and our opposite is 5,900. So because I have opposite hypotenuse, I know I'm going to use sine. If it was cosine, I'd have to have this down here, and I don't have adjacent hypotenuse. Oh, wait, why am I saying sine? Did I say sine before and mess it up? Oh, no, I'm right. What am I thinking? And then if it was here, in order for it to be tan, I'd need opposite adjacent. Woo, brain fart all of a sudden. So since I don't have the adjacent side, I know it's not going to be cosine or tangent. So now I know the formula is so sine theta. Well, because I'm using sine, the sine theta that they gave me is right here. They gave me this. So they gave me, wait, what's happening on your screen? Hold on, let me see what's happening on the thing. I am getting a lot of stuff going on. Can you guys see everything? Oh, okay, that's what's happening. Never mind. Okay, so then what's going to happen is now I know the formula is sine equals the opposite over the hypotenuse. They give me the sine value. They tell me the sine value is 0.0523. The opposite value is 5,900. And the hypotenuse value is x. So first, I'm going to put this over 1 and cross multiply. So when I do that, I get 0.0523 times x equals 5,900. Now, this is the same thing as like 2x equals 5,900. So you just divide everything by 2. Here we're dividing everything by 0.0523. This cancels, and so I'm left with x on this side. And then when I do the division, I'm left with 112,810.7. And then that's how you get it from there. Okay, let's jump to trig. So here's an example for inverse. All we're doing for inverse is finding the nearest degree. Because it asks for the angle measure, we are doing inverse. Angle, inverse. We do have to pay attention for which angle they're talking about because that's going to tell us which we're going to be using. So Remember, I know that sine is opposite over hypotenuse. So C is cosine, adjacent over hypotenuse, ca, and toa, opposite over adjacent. So we're going to pay attention to those pieces. Here it tells us that it wants D. Here's angle D. Because it wants angle D, we know that D is going to be our theta. That's the angle we're talking about. That's the angle that matters. Oop, I can get this one bigger. Okay. No. Okay. So now we know it wants D. So D is our theta. Based on that, here's our angle. So our right angle. So this is my hypotenuse. This is my adjacent. This is my opposite. In this case, because they give us all three sides, we know that what all we have to do is just pick any of the identities. We just have to make sure we get the right sides. So I'm going to have us pick, we'll do a cosine. Okay. So what we're going to do is we know that cosine D, cos inverse of cosine is adjacent hypotenuse. So the cos inverse of 20 over 29 is going to give me angle D. And all I did is instead of typing in the angle measure, because I don't know it, I'm going to hit the inverse. 7. Okay, and let's see if, nope, that's not helpful. Yep. Okay, so here's my trusty calculator. It wants us to do inverse. So I'm going to hit the second sine button that gives me the inverse function. And on your calculators, it'll probably say A. It just means inverse. That's fine. Then I'm going to put in 20 divided by 29. Now, you will not get a fraction button on the calculator for your EOC. They want you to know that fraction means division. So all I did is I picked two numbers. In this case, I chose adjacent hypotenuse. I didn't have to. I chose it. So it's cos inverse of 20 divided by 29. And that number that we get, 43.6, is the answer. Now, if I wanted to do it, let's say I wanted to do instead tangent. So I'm going to put in tan inverse of 21 divided by 20, because that would be opposite over adjacent. Okay, so I'm just showing you another example. I'm going to do second tan. That's going to give me my A tan. Then I'm going to put in 21 divided by 20. And again, I get the same value. Did I type it in wrong the last time? Oh, I did. I wrote it wrong here. This is 46.3. I was having a little dysgraphia. 46.3. Okay, so that's it. Let me see if they have one more that we can do that's not on this worksheet. Trig ratio worksheets. Is there another one that might be a little trickier? Okay, here's an example here. So let's look at one of these. Let's look at this one. And I don't think that's the right answer because it says cut out and arrange. So yes. So let's take a look at the one down here. Here we're looking for the angle measure. They only gave me two sides. So I have to pay attention to what those two sides are. Okay, cool. Then I'm going to move on. All right. Can we move to proofs? No, we won't give you those down here. All right. I'm still looking. Let me try to keep finding one. I wasn't thinking we needed to do proof, so that was my mistake. Okay. We will use this one. Okay. So right now we're going to just review some things that you need to know. Don't forget for congruence, midpoint, it divides it into two equal pieces. Angle bisector, perpendicular supplementary, most of those you know already. A reminder for things like this, reflexive property. Okay. You might have to add or subtract. And then the postulates, of course, being these right here. Now, there are similarity postulates. The similarity postulates we pretty much talked about were angle, angle, but there is a side, side, side similarity and a side angle, side similarity. In order for it to be side, 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 it's not equal sides for similarity, it's proportional sides. Down here, they have what he calls RAT and VAT, right angle theorem, vertical angle theorem, alternate interior angle. So let's kind of take a look and see where things play out. As a reminder, you're going to want to pay attention to where things are located. So in this case, we have our two angles here and here. The side is outside. Because the side is outside, if you're one of my students, I talk about how it's like Chick-fil-A sandwiches. You would never go to Chick-fil-A and then give you two pieces of bread and the chicken on the outside. You would get one at South Gwinnett High School. And so because of this, this is angle, angle, side, because the side is outside the two angles. That's different than down here, where the side is in between the two angles. So that's how we're going to get angle, side, angle. For some students, it helps for them to write. So it helps for them to write, this is a side, this is a side, this is a side. So it's side, side, side. Here, this is an angle, this is an angle, this is an angle. That's not one of the congruent symbols, so it's not enough information. Technically, it is enough information for similarity. Here we've got a side, we have an angle in between, we have a side right here. Okay. Here we have vertical angles. Vertical angles are congruent. So we've got angle, side, angle. So sometimes it might help. Just take a piece of paper, put it on top of the screen. Do not write on the computer screen. Put it over the screen, trace the shapes, and label it. That might help you be more successful. Don't forget if you see these little carets, these little arrows means parallel. Yep. So angle, angle similarity just means that if two angles, if corresponding angles are the same, then you can prove the shapes are similar. That's literally all it is. So in order for it to be proportional, you have to know that the sides are in proportion. But angle similarity, all it is if you have two corresponding sets of angles that are the same, then you know that the shapes are similar. So in this problem here, technically we have three sets of similar. So we know that this is angle. We can prove that they're similar. We can't prove that they're congruent because we don't know anything about the sides, but we can prove that they're similar. And the reason why you only need two angles is, remember, every single triangle has 180 degrees. So if you know two of them, you can do subtraction to get the third angle to be the same. Here, let's take a look at this one. The fact that this is parallel lines. The reason why they give you parallel lines is because they want you to notice here is a side here. Here we have another side. We have this side for the reflexive property. And then we have this angle here and this angle here because alternate interior angles are congruent. So because of that, we can prove it as side, angle, side, because alternate interior angles are congruent. Let's take a look at some proofs, because I know that's probably what you're interested in. Let me take a sip of water, though. Okay. I'm not going to write beautiful, so let's be good listeners. All right. It tells us that CB and AD are congruent. So we know that this is true because it's given. And I taught you, for my students, we write down what it is. We know that we have a side. Then it tells us that CB and AD are parallel. Again, that's given. And then this is what we're trying to prove is the triangle. Now, they're not going to mention parallel lines unless you need to use it. So what would CBD and ADB have in common? Well, some teachers have said if you notice that you can form a Z or in some way, you know you have alternate interior angles. I never told my kids that, but if that's how your teacher taught you, that's what it is. So these two angles right here, CBD and ADB, are alternate interior angles, are congruent. I'm going to put alt angles congruent. Okay, so now we have an angle. Here we have a congruent symbol, we have a side. Here we have a congruent symbol, we have an angle. Here we have a congruent symbol, both of these are sides, so we know that it's going to be side, angle, side. And the reason why BD is congruent to BD is the reflexive property. And that's it. Now, they might try to trick you. They might say BD is congruent to DB, but as long as it's the same line, it's totally fine. Let's look at another one. Here it wants to know, they give us the reasons, but we need to come up with the statements. It says given PL and YL. That's a side. PL and YL, that's a side. It gives us that A is the midpoint. Now, I talked to you about this in my classroom. If it has a midpoint in the statement, most likely the next reason is about midpoint. It kind of flows. I don't know how many types of these questions are going to be on the test. I know that it said these fall in congruence. Where is it? These fall in congruence, and 35% of the test has congruence in it. So right here, this falls into congruence and similarity, so it's 35%. But that congruence and similarity covers every single one of these things, which includes transformations and everything else. So if you figure there's like, what did we say? You were taking 73 questions, I think, on the test. So if you figure 73 and it wants 35% of that, well, 35 roughly divided by 3. So you're looking at 20 questions will relate to similarity and congruence. How many of those will actually be like how we're talking about? I don't know. Whoops, that was a mistake. Where did I just put that paper? All of a sudden, I lost my place. All right, we'll just get it again. Perfect. Okay, so we have our midpoint like that. So definition of midpoint, I'm hoping not a lot. If this is the midpoint, whoops, technical difficulties. If this is the midpoint, that means this side and this side have to be the same. So we've got PA is congruent to AY. Again, that's another side. Then it says reflexive property. Now you can have reflexive property for angles. I think the only time you might have reflexive property for angles is if you have like something like this and it wants this angle and you were saying that these two triangles are similar, then you could probably use reflexive property for the angles and then corresponding angles like that to prove that the shapes are similar. Nonetheless, in this case, it's going to be LA is congruent to LA. Again, a side which allows the triangles to be congruent. Please just make sure that when you, if you have to come up with congruence that you follow, like L goes to A, goes to P, L goes to A, goes to Y. So lay is congruent to lap. Let's see. Okay, here's two more. In this case, again, we're going to write our givens first, just like when we make a sub sandwich, we always want the breads on the top and the bottom and what we're proving in the bottom. The top, what we always want bread on top and bottom. So what we're giving goes always on the top. What we're proving goes always on the bottom. VO and RO are congruent, which is marked here. It tells us that PR and VE are parallel. That's given. Okay, and then we have to come up with the next ones. Now, on my paper, I reminded you that vertical angles form an X. So we're going to do something with these two angles. I'm going to label this angle 1 and angle 2. And the reason is vertical angles are congruent. Look for the X, look for the Z. What do you know already? How can you work from there? Again, they're not, vertical angles have nothing to do with parallel lines. So there's a reason why they mentioned parallel lines. They mentioned parallel lines because if we have angle side, we need these two angles. So I'm just going to say angle V is congruent to angle R. So we've got a side and we've got two angles. And that is alternate interior. And then now you would think, oh, it's just angle, angle, side, or side, angle, angle. Look at the order, though. Here we have an angle. Here we have an angle, and the side's in the middle. So it's ASA. So even though you know how many sides and angles you have, you might still need to take a breath to see exactly how many, what the order is. Is it angle, angle, side, or side, angle, angle? Couple more proofs. Lots more proofs. Geez Louise. Okay, let's look at this next one. It tells us that WOK is isosceles. That's given. Tells us, and then it says WO is congruent to KO. So we're going to have to say there, that's definition of isosceles. And again, as I told you, oftentimes if it's mentioned in a statement for one, it's going to be in the reason in the next one. Here they tell you R is the midpoint. That's given again. So then it tells you WR and KR are congruent. Why is that? Because definition of midpoint. Again, midpoints mentioned there, midpoints mentioned here. Then it tells you OR is congruent to OR. We know whenever the letters are the same, it's reflexive. If we label this, we've got a side here, a side here, and a side here. So it's pretty obvious we have side, side, side. But we're not done yet. There's something that comes after that. It wants us to know, why are these angles congruent? And the angles are congruent because of CPCTC. What does that mean? That means that corresponding, which means matching, CPCTC, parts of the O is silent, congruent, triangles are congruent. I don't know why I took up so much space for that, but I did. Okay. Most times, if you have something that comes directly after a triangle congruence, most time it's going to be CPCTC. Again, here, these all have triangle. This says angle. Because this is a triangle, it can only be one of the triangle theorems. Because it's an angle, that's why it's got to be CPCTC. Next. Why are you going away so much? All right. Let's see. All right, let's look at these next two. Okay, here it talks about midpoint. Okay, so it tells us that I is the midpoint. I is the midpoint, so that's given. Again, midpoint. Why would they mention that I is the midpoint of XM? Well, here's XM. I is the midpoint. So we know that. Okay. All right, I'll do a couple more and then, okay, hold on one second. Okay, so I'm going to finish this one and do one more. All right, so now it says midpoint, so I know that this is going to be, whoops. Oh, it won't even let me do it. Okay, so it's these two pieces are the same. XI is congruent to XM. Those are sides. It mentions the same thing here for these two. So we've got AI, so this is given, equals OI, again, midpoint. Okay, great. These two angles are vert. So then we've got side angle side. Okay, good. Great. Anyone else have any more topics? Down here, just for right angles, remember that hypotenuse leg. That was the only other one I wanted to show you. Remember that the only time, though, real quick, that you can do hypotenuse leg is you have to make sure you have right angles. Hypotenuse leg only works for right angles. Okay, well, since no one else is responding, we are going to stop here. Thank you very much for sticking with me. I think you guys should be good. Please get sleep tonight. You're welcome to watch us again. I don't think you need to, but please get sleep tonight. Also, please, please, please pay attention to this, the crazy quick review. On the bus tomorrow, you should go through and just read this one time. Okay. So that is the last thing. And other than that, I'll be on remind till about 8 o'clock. So if you have any other questions, you can feel free to let me know. And that's it. So yay, you made it 2.5 hours. Yay. All right. Bye, y'all. You got this. Yay. Good job. All right. So we're going to X this out, close all tabs. Going to go here.